Hey, hello friends. The problem that we are going to look at today will be a dungeon game. So let's read the problem statement first. So the demon has captured the princess and imprisoned her in the bottom right corner of the dungeon. So if you look at it, so the princess is being captured here. So here is the princess. Okay. And yeah, now the dungeon consists of M cross N rooms laid out in the 2D grid. So it's a two-dimensional array kind of. Our Valiant Knight was initially positioned at the top left room. So basically the knight position is here. So knight is positioned here. If you look at, okay, and must fight his way through dungeon to rescue the princess. The knight has an initial health point represented by a positive integer. If at any point his health point drops to 0 or below, he dies immediately. So there is a health point that is assigned to some knight, and if that point drops to 0 or below, he dies immediately. Okay. Some of the rooms are guarded by demons, so represented by some negative integers. So basically, if you look at, there are few rooms which are kind of uh, decrease the health point of the knight if he goes to that room, and there are few rooms which are like kind of, this room is number having 2, which is a positive value, so it increases the health point of that knight. Some Yeah, that's what it is. So yeah, so the knight loses health upon entering these rooms, which are kind of negative numbers, and other rooms are empty, maybe 0, or contains magic orbs that increase the knight health, that are kind of positive integers. To reach the princess as quickly as possible, the knight decides to move only rightwards or downwards. So this is kind of a catch. So if you look at it, he can move only right or downwards. These are the two moves that are possible for the knight. Okay. Now return the knight's minimum initial health so that he can rescue the princess. So we need to tell if the knight moves from this box, right? This is the box right now the knight is located at. He needs to move to this box where princess is located. We need to figure out how much minimum health units should the knight have so that he can reach safely to this location, and he can only move right and downwards. So these are the two moves that are allowed for the knight. Okay, now note that any rooms can contain threats or power-ups. Even the first room the knight enters, the bottom right room where the princess is imprisoned. Okay, that's okay. Now let's take an example to, like, I'll show you this problem statement more accurately maybe. So for example, knight is here, right? So as soon as he enters into this room, he loses 5 units. Okay, so he should at least have kind of 6 units available, so that as soon as he enters into this room, he won't die, right? If he would have had, for example, 5 points or 5 units of health when he enters into this room, then he would die, right? Since he loses these 5 points, and now his health points will be kind of 0, and at 0 he'll die. Okay, so we should keep him alive, right? So we need to give him kind of +1 health, which is required, right? So 5 is required just, and +1 6 is required so that he won't die, correct? So I hope you understand the logic of this. Okay, now whenever I read the question and I see this, if he's only allowed in right and down, so kind of DP comes into my mind. So let's see if we can solve it through that, or maybe we can form some recurrence relation. Okay, so for now, let's take an example. Think backwards, right? Since I mean the moves are right and down, we'll think in terms of up and maybe left. So left and up, we'll think in that direction. For example, we are in this room. Okay, how much health units, or maybe how much health points a knight requires here? So he requires 7, right? Let me use the red color. So he requires 7 points, correct? So if he would have had kind of 6 points, he would die, right? Since 6 minus 0 will be, as soon as he enters into this room with 6 points, he'll die, correct? Since 6 minus 6 will be 0, and at 0 he'll die. So he needs at least 7 so that he can survive, and uh, I mean he can save the princess. Okay, now he must have come here from here or here, right? I mean, since he can only move right and down, so he must have come from here or here, right? So since we need 7, we need a health of 7 for entering into this room. How much we need here? So if we want to enter into this room from this room, how much we will, how much health point we'll need here? That will be 15, right? I hope you got my point how it is 15. So 15 is 7 plus 8. Okay, so since he's having 15 here, so 15 minus 8, he'll be having 7 here. So as soon as he enter into this room with a health point of 15, he'll reduce 8. Okay, then how much point will be left when he enters into this room? 7, right? That's what we wanted, correct? So he'll lose again 6, and 1 will be left, so he can save the princess. But now assume if he comes from this path, right? If he comes from this room, how much points he needs here? That will be 7 plus 7, that is 14, right? 14 points he requires. Okay, so you can assume in the blue I am writing what is the original array. I mean, original array means the point that he gains or loses as soon as he enters into this room. So that is denoted in blue color. And in red color, I am denoting the health points which he requires as soon as he enters into this room to get to save the princess or to reach to this room. Okay. Now we calculated for these two rooms, right? Now let's see for this room, right? For this room, if he comes from, he can only enter into this room. He can enter into this room from here or here, right? Okay. So if he wants to enter into this room, how much he needs in this room with kind of -6 value? He requires 20 points, right? 14 plus 6, 20, correct? Similarly, we can easily calculate it for, like, here he requires 25, here he requires kind of, now since he requires, so 25 he needs here, so 25 minus 5 is 20, 20 minus 6 will be 14, 14 minus 7 will be 7, and 7 minus 6 will be 1, so he can save the princess. Now here, think about this. For example, he's in this room, right? He's gaining 4 points here, and after entering to this room he needs 25, correct? So he needs 21 here, right? 21, with 21 he can gain 4 point here, which will add up to 25. I hope you are clear about this. Let me repeat this point again. So since the number in this room is positive, So he's gaining 4 points as soon as he enters into this room. So for entering into this room, he needs 25 points, right? So how many points he needs before entering into this room? 21, right? With 21 he can like gain 4, that will add up to 25. So with in this room he can enter with 25. So that will like we can, I mean, be consistent through this, correct? Now let's see, we want kind of 15 points here before entering into this room. So how many points we'll need before entering? We need 8, right? 8 plus 7 is 15. Similarly, we need 3 here, correct? 3 plus 5 is 8. Okay, so we are sorted for the outer boundary, right? So for the right and the bottom boundary, we are kind of sorted. Now let's pick up this thing. Okay, now he can, from this he can go to here or down, right? Because he can move either right or down, correct? So let's consider he is sitting here, okay, in this room. Now how much health points he needs, minimum health points he needs to reach to save the princess, correct? So minimum would be either he can go to this room, right, or he can go to this room. How many points he need to go to this room? 12, right? 12 plus 2, 14. He can enter into this room. How many points he should have to enter into this room? That will be 13 plus 2, that is 15. So minimum how many? 12, right? So let me again put it into red color. So minimum 12 is required, right? So it will be kind of minimum of 14 and 15 plus 2 minus 2, sorry. So minimum of 14 and 15 will be 14 minus 2, that will be 12, correct? So 12 points you need before entering into this room. Okay, now let's see for this room now how many he needs, since he can enter here or here, right? So how many points he needs for this? This will be minimum of 12 and 20 minus 3, correct? That will be 9, correct? So he can go in this direction rather than going this direction, because here he needs minimum health points, right? So we need to figure out minimum health points he needs from this box, right? So as soon as we now keep calculating, we can reach the box here and this will give us the answer, right? So let's see now, for example, we are okay, now so the logic is minimum of these two boxes. So for example, we are sitting at x comma y, for example, this is our x comma y, right? This is our x comma y. Which is this one? This will be kind of x y plus 1, right? And this is x plus 1 y, correct? So x plus 1 y and x y plus 1, these boxes we need to check, these two boxes we need to check. Okay, sorry, right? These two boxes we need to check for calculating the value of this. For example, we call this array as dp. So dp of xy, to fulfill dp xy, we need to check kind of the minimum of dp of x plus 1y and dp of x y plus 1. Okay, and we need to subtract the original array's value of x and y. Okay, if it is negative, I mean it will be added up. If it is positive, it will be subtracted. Okay, that's how we'll calculate it. Now it could happen that when we subtract this, right, this whole value will be negative, okay, or 0. So in that case our answer should be 1, correct, since only we need at least health units of 1 or maybe health of 1 unit to survive, so it should not be negative. Okay, so yeah, that's the approach that we came up to. Let's try to code it now. So I'll again show you once. So for example, we are at box, say this is x, y, right? Now we have two boxes, x plus 1y, or maybe this will be x plus 1y, and this will be x, y plus 1. Okay. Now this is the value that we want to fill. For example, we are in DP array right now. So we need to take the minimum of this and this. Okay. And we need to subtract the original xy value from that. But this is from the original array. For example, we are at the DP array. So from original value, we'll take the original of xy, subtract it from the minimum of DP of xy plus 1 and x plus 1y. Okay. If it is negative or 0, we'll consider 1. Okay. Otherwise, the value which is coming from there. Okay. Now, if we see, okay, yeah, sounds good to me. Let's code it and let's see if we should be able to code it, right? Okay. And just to resolve the compilation error we're returning for now. Okay. Now, take a DP array that I was telling you about, right? Of size, I mean, okay. Now we'll now, for example, first of all, if we have this array, right? If we have this array, let's think about the base case. For example, now we need to fill this box first. Okay, this box needs to be filled. The value of this will be kind of if this is greater than 0, then our value will be 1. We need at least 1 health. Or if it is negative, then we need kind of absolute of this plus 1. I mean, at least that much. Okay. Now we'll see how we should go about it. Now we need to fill dp of n minus 1, or maybe let's see, because n is, okay, m is the number of rows, right? So we can say dp dot length. Okay, let's initialize the variables first. N is equal to, this is what it is. Okay, now you'll initialize the array m by n, right? Now you'll say dp of, this is, I'm initializing kind of m minus 1 n minus 1. Okay, this will be kind of this will be kind of 1 plus, or maybe math dot min of. Okay, max of, ठीक है, we'll say math dot max of. So basically we need to get this value, which will be dungeon of m minus 1 n minus 1, and add 1 to it, right? So if we add 1 to it, if it is negative, okay, I need 1 minus, if it is negative, then this will be adding up and this will be more than that. If it is positive, then we need kind of 1. Yeah, that will work, right? So if dungeon m minus 1 n minus 1, this is negative value as we have right now, this is 6 minus 6, right? So 1 minus minus 6 will be 7, and which is greater than 7 and 1, 7 will be greater, so 7 will be assigned here, right? This is 7, correct, the value in red. Okay, now if it is greater, I mean, if would have been 6, then we have 6 plus 1 minus 6 would be minus 5, which is lesser than 1, so 1 would be our answer, right? So that's how we'll achieve this. Now we'll fill now this row, right? This row from, say, which is the column. The column is n n minus, oh sorry, this is m rows, right? N columns, n minus 1th column. Okay, let's fill n minus 1th column for, so dp of n minus 1, right? Column will be n minus 1. Rows will vary, right? Rows will vary, correct? I equal to m. So m minus 1 is already filled. Now m minus 2 we are filling, right? From m minus 2 to minus 2, I is greater than equal to 0, I minus minus, right? So we are filling now dp of, so this is the n minus 1th column. Similarly, we'll fill m minus 1th row. Okay, so if we'll fill that, so what would be our, what would we say? So I is equal to n minus 2. Now dp of m minus 1 I is equal to, okay, so yeah, so here I'm initializing kind of the base things. So now when we are fulfilling this, so what we need is, we calculated this, right? This is already calculated. For this we need kind of the health here plus, or maybe I'm subtracting the original value, right? So mhm, I'm subtracting the original value. So I'm checking first of all dp of I plus 1. So I'm at ith row, right? So I plus 1 row I'll check. Same column. Same column I plus 1 row. I'll check and I'll take that value, subtract this value from it, and I'll take again the math dot max of this comma 1, right? This is fine, right? Yeah, again, now similarly here I'm filling this this minus 8 column, right? Uh, so I need to fill 15 here. So for filling 15, I'm checking the kind of the same rows next column value, same rows next column value, right? And I'm subtracting the same value m minus 1 I, and yeah, if this is math dot max of, right? So these two rows I have already fulfilled. Now I start fulfilling from here. Okay, so this let me see how will I fulfill this. Okay, now let's see, I've already fulfilled this. Now for int I equal to, now n minus 2 I fulfilled, right? Yeah, hmm. So I need to kind of fulfill this whole array, correct? Which is from, this is n minus 1 m minus 1, this is n minus 2 m minus 2, correct? So just formatting this. Okay, now fulfill this, then this, right? Now this again. This is how I need to, first of all, this row, then this. Okay. Um, I'm at this row, correct? Now I'm filling all the columns first. Okay. Just thinking out loud. So, okay, I've already filled this row, or maybe this column and this row, right? Now I'm at this position. I can fill this value from this and this. That is okay. Now, in what order I should fill? So I want to fill it, say, this row, this one, kind of, this is how I want to fill these. Correct. But who is stopping me? For example, I fill this, right? Now I can fill this. I can fill this. Correct. Because I need to check this. For filling this, I need to check this and this, right? For filling this, I need to check this and this. So that I can do this and this, this and this. Okay. For this, this and this. Okay, let's see. Now I'll say dp of ij is equal to, again this will be our key, which is kind of dp ij if I want to fill. So I should look at I plus 1 j, okay, and I need to look I j plus 1. I'll take kind of the minimum of this two and subtract this. Okay, I'll take minimum of these two and subtract this. If my minimum minus this is negative, okay, let's see, if it is negative then, or less than 0, it will be 1 then. So again, if I'd say math dot max of this comma 1, right? If it is positive, then we'll pick the positive value. If it is negative, we'll pick 1. That's okay, right? Now j minus minus, sorry. Yeah. This filling kind of the jth, I mean, this column wise it is fulfilling, right? This, these, these, then these, right? So this, and this, correct? Then this, this, this. That is okay, right? I should be able to fulfill in that order, yeah. Now I can return kind of TP of 0, 0. That would be my answer. Okay, let's visit this again, or maybe try run. So first of all, I took the row. How many rows are there? How many columns are there in each row? Created the new DP array. Set the value of m minus 1 if it is say 1 minus of that value, comma 1. If it is say negative value, so 1 minus 5, 6, 6 comma 1, max is 6. If it is positive, then we need 1 at least. That is okay. Now we fill the n minus 1th column. Okay, so column is n minus 1. Row we need to vary. We need to vary rows from 0 to m minus 2, right? Or maybe m minus 2 to 0. So yeah, since m minus 1th row we have already filled here, so m minus 1. So I will vary, and this column would be same for every, and I'll check the same column value. Dungeon will be should be same, and DP should be kind of, yeah, the next row I need to check, yeah. So I need to check kind of the next row. So for example, I'm fulfilling this, I need to check here. If I'm filling this, I need to check here. Next row I'm checking. Similarly, yeah, right. Similarly, next column I'm checking right here. Okay, now this is for m minus first row. This is for column, this is for row. So m minus 1, m minus 1, right? So similarly, same dungeon, and this is kind of next column. Okay, now yeah, ideally this should work. Let's see. Let's try to submit it. Fingers crossed. Oh, okay, now debugging is tough. Just saying, okay, for case 2 it is 1. That's fine. It's a no brainer. So minus 2, minus 3, minus 3. Okay, this is the array, right? Let's copy this one. Okay. Now dp m minus 1 m n minus 1. Okay. For example, if we read this, we are saying next row, same column, next row, same column, and next column, same row. Oh, that's the problem. It should be ij. Sorry, yeah. It should be ij. Yep. Let me. This should be I and j, right? Yeah. Accepted. Submit. Oh, array out of bound. It is saying. What is an array out of bound? Since we are saying I plus 1j. I is equal to n minus 2, 0 to n minus 2, right? I is greater than equal to 0. I minus minus j equal to n minus 2, j is greater than equal to j minus minus. So we are incrementing j, we are incrementing I. Okay. Yeah. What could be? Oh, yeah. I mean, here we should iterate over m, right? So m should be here. So if we change it to m, let's try submitting it now. Yeah. So hope you liked the video. So yeah, please like, comment, and share. Thanks a lot.